Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 7-3 Extra Practice Solutions on Parametric Equations. For this one, to write this in rectangular form, I notice first off that I can do an easy substitution. Wherever I see a t, I can replace that with an x. Rectangular form, you just basically have to have y and x and no t in the formula. So I'm just going to replace this t squared with an x squared. And y equals negative x squared over 5 is going to be my rectangular form. This, since we only have a single squared term, must be a parabola. On this problem, since I noticed that we have two trig functions, I'm going to try to isolate and square those trig functions and use one of my Pythagorean identities to get rectangular form. So I'll start with this x1. So I'm going to divide both sides by 7. I can write cosine of t equals x over 7. And then if I square both sides of this, I get cosine squared equals x squared over 49. Over here, I'm going to divide both sides by 7 to get y over 7 equals sine of t. And then we can write sine squared equals y squared over 49. So I have an identity with a cosine squared and sine squared in it. That would be the sine squared plus cosine squared equals 1. So I can write x squared over 49 plus y squared over 49 equals 1. And if I wanted to, I guess I could multiply everything by 49 to make it look a little bit more circly. But we know since we have two squared terms, they're both positive, and they both have the same coefficient, this must be a circle. On this problem, since I have two trig functions, I'm going to isolate them and square them and use a Pythagorean identity to get rectangular form. So for the x1 here, I can add 2 to both sides and divide by 11. So we have sine of t equals x plus 2 over 11. And then if I square both sides of this, I have sine squared equals x plus 2 squared over 121. Over here now, for the y part of this, I'm going to add 6 to both sides and divide by 4. So y plus 6 over 4 is the same as cosine. And then I can square cosine, and over on the right side, I'll have y plus 6 squared over 16. So I have the identity cosine squared plus sine squared equals 1. So I can write x plus 2 squared over 121 plus y plus 6 squared over 16. All of that equals 1. Now I notice here that I have two squared variables, so it's not a parabola. They're both positive, so that's an ellipse or a circle, and they have different a and b values, different coefficients if we expand this all out. So that means I must have an ellipse. On this problem, since I have two trig functions, I'm going to try isolating and squaring them, and then I'll use a Pythagorean identity. So for the first one, let me add 2 and divide by 3. So cosecant equals x plus 2 over 3. And then if I square that, I have cosecant squared equals x plus 2 squared over 9. Over here, let me add 2 and divide by 2 to get cotan equals y plus 2 over 2. So then I can write cotan squared equals y plus 2 squared over 4. And there's an identity that has cosecant squared and cotan squared in it. The identity would normally say 1 plus cotan squared equals cosecant squared. But I can get cotan and cosecant squared on the same side if I subtract cotan squared from both sides. So I can write cosecant squared minus cotan squared equals 1, just based off the original identity, which means I can write this stuff, x plus 2 squared over 9, minus y plus 2 squared over 4 equals 1. Since I have this minus in here with two squared terms, this has to be a hyperbola. For this problem, since I have two trig functions, I'm going to isolate and square them to get a Pythagorean identity that I can use. So over here we've got x plus 2 divided by 4 equals sine of t. So then sine squared equals x plus 2 squared over 16 if I square both sides there, and that needs to be an x plus 2 squared. Over here with the cosine one, I'm going to subtract 1 and divide by 5 to get something that equals cosine. And then if I square both sides here, I've got cosine squared equals y minus 1 squared over 25. So now I have the identity sine squared plus cosine squared equals 1. So x plus 2 squared over 16 plus y minus 1 squared over 25 equals 1. Since they're both positive squared functions, that's going to be an ellipse or a circle, and since they have different denominators, that's got to be an ellipse. For this problem, since I have two trig functions, let me go ahead and isolate those and square them so I can use one of my identities. So for this first one, I'm going to subtract 2 and divide by 2. So that's x minus 2 over 2 equals tan of t over 2. And then if I square both of these, that's tan squared of t over 2 equals x minus 2 squared over 4. Over here, let me do pretty much the same thing. So we have y minus 1 over 3. And then squaring both sides, I've got secant squared equals y minus 1 squared over 9. Now the identity that has tan squared and secant squared in it, we've got 1 plus tan squared equals secant squared. So if I subtract tan squared from both sides, I can write secant squared and tan squared on the same side of the equation. So now let me substitute what I have here for the things down there. So we have secant squared, that's going to be y minus 1 squared over 9 minus tan squared, so that's x minus 2 squared over 4. Since I have two squared variables that have a minus between them, that means I must have a hyperbola. On this problem, with all these trig functions involved, I'm just going to try to isolate those and square them so I can use a Pythagorean identity. So for this first one, we've got x minus 2 over 2 equals cosine, and then cosine squared equals x minus 2 squared over 4. On this one, we have y plus 2 over 2 equals sine of t. So then sine squared equals y plus 2 squared over 4. I can write cosine squared plus sine squared equals 1, my identity, and then plugging these things in as a substitution. Instead of cosine squared, I have x minus 2 squared over 4. Instead of sine squared, I have y plus 2 squared over 4. And if I wanted to, I could multiply everything by 4 to get those 4's out of the denominator. Something in this form, since I have two squared positive variables with the same coefficient on x squared and y squared, this all must be a circle. For this problem, I'm trying to write this in rectangular form and identify the shape. So basically, I need to get x and y in the same equation and have no t's left at all. So what I'm going to do is I'm going to try to substitute for t over here with something that t equals on this first equation. So to isolate t in my first equation, I'm going to subtract 2 and divide by 3 on both sides. So now wherever I see t, I can replace that with x minus 2 over 3. So over here then, I can write y equals negative 9 times x minus 2 over 3 whole thing squared over 2 minus 3 times this whole thing. And then that plus 3 halves is the same as before. All right, I'm going to simplify this a little bit. So one thing I'm going to do, I can square this parentheses. That leaves me with x minus 2 squared over 9. But this over 9 and this 9 are going to cancel. So I really just end up with negative x minus 2 squared, the whole thing over 2. And then over here, these 3's cancel, leaving me with just minus x minus 2. Still have the plus 3 halves. Let me go a little bit further. This x minus 2 squared, I can expand that. That's x squared minus 4x plus 4, all over 2. And then let me go a little bit further. So I can divide all of these things by negative 2, essentially. So we have negative x squared over 2, or negative 1/2 x squared. And then we'll have positive 2x minus 2. Over here, this is going to be distributing a negative minus x plus 2. Still have the 3 halves. And then finally, the negative 2 and the 2 can cancel. We have 2x minus x, which is just x. We have x squared over 2. Negative that is not going to change. So when the dust settles, we have negative x squared over 2 plus x plus 3 halves. After all that work, we see that this is definitely a parabola. For number 11, to turn these into rectangular form, let's isolate the trig functions. So sine equals x over 3, and sine squared then is x squared over 9. Over here we have cosine equals y over 3. So cosine squared equals y squared over 9. Well, we know that sine squared plus cosine squared equals 1 in general. So that means in this case, x squared over 9 plus y squared over 9 equals 1. Multiplying by 9, we get the equation of a circle.